Hello again. This video we're going to go through some definitions of quality. So first off, we're going to start with the Kano diagram. So the Kano diagram, it helps us to understand a customer's expectations in various aspects. So let's draw the diagram first. So we've got our grid here. At the bottom of the grid, we have the unhappy customer. At the top of the grid, we have the happy customer. Things on the right side, we have things that we have done very well. We've executed these completely and fully. And things on the left-hand side, we haven't done anything at all with. So we'll explain this a little bit more. So the first one I want to talk about are the performance factors in Kano's diagram. Performance factors are generally things that we will measure in numbers. These we can directly compare one thing against another. Then we have the delighters. Delighters are the things that we don't expect, but make us happy when we discover them. They're not generally going to be something that is going to cause us to directly choose one thing over another, but if all else is equal, we will choose things based on delighters. The next one is expected. These are the things that we just expect to be there. We don't have to ask for them. We are disappointed if they're not there. If our expectations are not met, we simply will not purchase that. And then the reverse qualities. So reverse qualities are things that the better we do, the less happy the customer is satisfied with our product. So let's go through some examples here. So we're going to talk about a car. So in a car, things that are delighters are generally things like a heads-up display, a sunroof, right? These are the exciting things. These are the cool features that you wouldn't necessarily buy a car based on, but you're excited that they exist. Next one, performance. These are miles per gallon, miles per hour, horsepower, number of cup holders, number of seats, cubic feet of cargo space, all that kind of stuff. Stuff that we can directly compare one to the other. Expectations, large windows. At this point, we just expect cars to have large windows. That's something that we've become accustomed to. Automakers are putting more glass in. Another expectation we have now is generally we consider power locks an expectation. And then reverse quality. So these are things like child locks, the back windows that only roll halfway down, the dinging seatbelt reminder. I'm not saying you shouldn't wear your seatbelt. I wear mine. You should wear yours. But a lot of people find the seatbelt reminders to be annoying. So we try to ignore those, and they're constantly annoying us. So the better our seatbelt reminders are, so if it starts dinging the moment you get in the car, it's extremely loud, there's flashing lights and sirens, right? That kind of stuff is going to annoy the customer, the better job that the car maker does of doing those things. So those are reverse qualities. So then we need to understand that over time, these evolve. So power locks used to be delighters. Many years ago, this was not a standard option on a car. This is something that was very exciting. Then it transitioned to become a performance. So power locks were something that you wanted to have power locks in all four doors or more if you have more doors. You wanted the ability to be able to open your power locks from outside of the vehicle with the remotes, all that kind of stuff, right? So that was having a remote was something you could directly compare one competitor versus the other. And now it's just expected. Almost all new cars are going to have power locks that you can open with a remote. Now, at this point, we should talk about market segmentation. Understand that all of these, delighters, performance, and expectations, are all based on the market segment, right? So refer to your marketing classes on how we break down segments based on age, gender, income, familial situation, all that kind of stuff. But once you get into a market segment, then these are generally common throughout the segment. All right, enough about Kano. Now let's talk about our 8 dimensions of quality. How do we define quality? Okay, performance. You will find that performance, these are much the same as in Kano's, right? These are the primary traits. They are measurable, right? Like I said, they're similar to Kano's definition. All right, things like acceleration, 0 to 60 time, horsepower, right, miles per gallon. We kind of talked about these. All right, here's the largest engine in the world, turning out 107,000 horsepower. Right, so that is something that in the dimension of performance, right, is high quality. Next is features. So these are the things that make you say, ooh, fancy, right? These are nice to have, but they're not necessary. These are, in the 8 dimensions, these are very similar to Kano's exciters. Again, example, my truck, I have a Ford truck. I have an app that talks to my truck. My wife's Subaru has an app that talks to the Subaru. We can schedule starts. We can set the air conditioning, all that kind of stuff, right? Retractable mirrors. This is not something that you are going to buy a car based on having mirrors that fold in or retract, but this is something that's nice to have, right? And here's CarPlay, right? This is Ford's Ford and Apple's app here. Next one, reliability. We define reliability as, does it start when I turn the key? One of the big metrics we use is mean time to failure. So this is time from when you first put it in service until the first time it breaks. Mean time between failures. So this is the average time between when you fix it and it breaks the next time. So how much run time you get between break time. Availability or uptime percentages. Overall equipment effectiveness. These are all things that we use. These are metrics we would use to define reliability. So this is what the graph looks like. So mean time between failures. Here we have our uptime, our downtime. So between when it first fails and when it next fails, the mean time to failure, right? Mean time to repair. These are all examples of things that we use in reliability. I'm not expecting you to be able to recite any of these, but simply be able to explain, what is reliability in your own terms. And the easiest way to think about that is, does it start when I turn the key? Durability. It's very similar to and linked to reliability. Mean time to first failure and usage is often considered part of durability. So are we using this in roughly, or do we have, is this in rain, snow, hot weather, cold weather, dusty environments, actual use, right? So how many hours, how many miles, right? That kind of stuff, versus how many years we've actually owned it. So you can think of durability the same way as you think of reliability, just with environmental factors taken into consideration. Serviceability. These are things like, how easy is it to take apart? So it's very common now to use permanent fastening like gluing and welding because it's cheaper than bolting and screwing things together. The iPhone is not designed to be taken apart, right? A lot of stuff is that way. We don't use threaded fasteners. However, if something is designed with high serviceability, things like the oil filter in your car, how easy is it to access that? Versus if the oil filter were welded in place, it would become an entirely different operation to take that apart. The example again, the oil in your car is designed to be done fairly easily, and the battery in your iPhone is not designed to be replaced. We generally talk about mean time to repair as a part of serviceability, and again, we saw this graph. All right. Conformance. So you won't ever need to calculate this, but we do talk about the Taguchi loss function. So Taguchi loss function tells us the further deviance we have from our goal value, right, the further out our distribution is, the greater the loss is. So that the taller the distribution, right, the more precise, the smaller the standard deviation, the less loss there is. This is conformance to either stated or implied standards or norms. We measure this using the Taguchi loss function. And we talked about CP and CPK. Don't worry about PP and PPK. As far as you're concerned at this point, they're exactly the same thing. Okay, but this is how well does it conform to something you expect. If you expect a can is 12 ounces, is it 12 ounces, right? Is it exactly what you expect? Is your shoe size, if you're a size 9 shoe, does it actually fit your foot? Aesthetics. These are very subjective. These are extremely difficult to define. Does it look, feel, smell nice? We talk about the new car smell as being one of the key examples of aesthetics. I would argue that the house in the picture looks nice. Some of you might have different aesthetics. You might feel different ways about different things. All right. Kind of similar to aesthetics, but different is perceived quality. So again, aesthetics are very subjective, so is perceived quality. Perceived quality is based on reputation. So how do we measure the new car smell? That's difficult. How do we measure reputation? It's a little bit easier. We do this with a lot of surveys. This is based on word of mouth, based on our experiences, based on others' experiences versus any amount of data. So these are things like the Toyota versus Infiniti discussion. Are they the same vehicle? Yes, with slight changes. Is an Infiniti a better vehicle than the Toyota? Right, that's all up to perception. When you look at, we've got the auto industry graph to the right here. You see that there's actually very, very few car companies and a lot of brands, right? And they all, as you can see, they all own each other, right? So there's not that much difference between cars, and you can argue this, right? As some might argue. All right, that's all I've got for this one. Have a great day.